Welcome. We're going to continue our discussion on electron geometry. It's the first thing we're going to do. And our job is to take a given molecule, whatever molecule I give you, you're going to develop decrypted codes like what you see here. Again, like I said, for people in the online environment, you do not have to memorize this table. Okay? And then based on the decrypted code, you would then determine the electron geometry. So let's go ahead and see how this works. So as I said, the one thing that you have to just know to use is the Roman numeral. And if you look, carbon's Roman numeral is 4A. And chlorine's Roman numeral is 7A. What does that mean? That means carbon has 4 valence electrons, and each chlorine has 7, but we have 4 chlorines, right? So it's 7 times 4 is 28 electrons total. That means the molecule itself contains 32 electrons. Now, how do we construct the structure? That's the first job to do. Well, if you look at the molecule, there's always one molecule that's least in count, so that goes at the center. Yeah, the molecule that's least in count always goes at the center, and the element that's in more count always goes on the outside. Now, carbon has 4 electrons, so start putting the 4 electrons around. Now, what did I say in terms of what a bond is? A bond is made up of 2 electrons, period. So carbon has 4, and we have 4 chlorines. Just put them anywhere you like around the molecule. Doesn't have to be in any particular corner of the screen. Just put them right somewhere around. And each chlorine has 7, right? Right? We are going to use 1 electron from each chlorine out of the 7, okay, to pair with, each electron on the carbon, right? Which leaves each chlorine with 6 electrons, doesn't it? 7 minus 1 is 6 electrons, right? So 6 electrons can be shared as pairs of 2. And that's exactly what I am doing right now. Right? And that's it. We have officially constructed the structure of CCl4. Now, how do we construct this decrypted code? The central element is referred to as A. We only have 1 central element, so A. There's 4 outer elements. Each element is given the symbol X. So there's 4, so AX4. Now, sometimes a central element have what is called lone pair. These are called lone pairs. What do you see here? These are lone pairs, but they're on the outer atom. We don't have any on the central atom because we had 4 electrons and they are evenly paired with 4 chlorine atoms. So the central element does not have any lone pair. So this is the decrypted code. So AX4. And what does AX4 corresponds to? Tetrahedral. And typically, a molecule with S for E is polar, and a molecule with no E is typically nonpolar. So is this molecule polar or nonpolar? It's nonpolar. There are exceptions. We're not going to get into exceptions, at least in this course. Similarly, let's do it for PCl5. Phosphorus is 5A. Chlorine is 7A. So phosphorus has 5 electrons. And the 5 chlorines each has 7, so it's a total of 35. And the net total is 40. The element that's least in count goes at the center, and it has 5 electrons, so just spread them around. And then you got 5 chlorines, so spread them around as well in such a way that they're aligned with wherever you put the circles for the phosphorus. we're going to use up 1 electron on each chlorine to bond with 1 electron on the phosphorus, which means it leaves each chlorine with 6 electrons. We're going to circle them as pairs. Now again, you have an option to not show it or show it, but I always show it just to show my level of work with respect to drawing electron structures. However, you also see some textbooks don't show them. So we see that we have 1 central element, 5 outer elements. There is no lone pair on the central atom. You must have a pair that's left unused. A pair means 2 electrons. There's none, so it is nonpolar because it doesn't contain any X's, E's, and AX5 is trigonal bipyramidal. And that's it. So I'm going to come back with one more video on molecular geometry. In the same video, I am also going to leave you with some problems to practice. All right? It's very simple. Very, very simple. All right? All right, so stay tuned.